All right. Let's see here. So we're starting chapter 5 today, which is trig. I don't anticipate that we'll get very far. Let me just paste this in here because we don't have very many days left. I know, so sad. But that's okay. That's okay, we'll survive. Yeah, what do we have left? We've got today, Friday, Monday, Wednesday, that's it. So, and I've got a day of final exam review, which is more, an outline of what to expect on the final exam and stuff like that. And so got that for Wednesday next week and just quickly running out of time here. So what I anticipate getting through is really not very much at all, I guess. Probably through 5.3. Introducing points on circles. Whoa, I don't know what happened. I don't know where I was. Oh, dang it. I know I wasn't at 5.4. Maybe I pressed it. Whoa. Okay, this looks good. So circles, angles, points on circles, using sine and cosine. We'll call it there. Okay. So starting with circles. I'm going to do something weird here. Let's remember Pythagorean theorem, which I think you're all okay with. I know you are. So Pythagorean theorem states that the sum of the squares of the legs of a right triangle, so a right triangle is one with 90 degrees here, just as a little refresher. So this is 90 degrees. And so it's a right triangle. Right triangle, oops. Which is equal to a right triangle, just in words. And is gonna, so the sum of the squares, so if you add up a squared plus b squared equals c squared, but in words, right, we read it as the sum of the squares of the legs. So the adjacent and the, I guess, opposite, weird. Not really. I take that back. We're not there yet. We don't have an angle. But a and b, sum of the squares will equal the sum of the hypotenuse. And so we're going to use this a squared plus b squared equals c squared today. How are we going to get from there to the equation of a circle? Let's do that. So if we want to find a distance, and let me just remove this so it doesn't look weird. We want to find the distance between 2 points. We can do that. Find the distance between -5, 2, and 1, 4. So just to visualize this thing, I look at my different values of x that I need to plot and just make sure I have room for both of them. And then I look at my different values of y and just make sure I have room for both of them on my sketch. So something like this maybe. So, or like that maybe. Why? Because I need 1, -1, -2, -3, -4, -5. And then I need 1, 2, it's just a sketch. -5, 2. Let's put that 2 on this line here so it's easier. 2, making this 4 conveniently. Negative 5, 2 is here. 1, 4 is roughly here. Right, going back to coordinates. Now we want to find the distance, which implies kind of as the bird flies distance. So we want to know what this distance is. Hey, looks pretty good. All right, we can find this distance, and then we can find this distance, and then all of a sudden we have created a right triangle, which we know how to work with, right? So think about how you would find each of these distances, right? If you want to find this distance here, what are you going to do? You're going to take probably 4 minus 2, right? And so here, let's see, this, I've run out of colors. Fine. So here, this distance, let's call it A. 4 minus 2. If you did 2 minus 4, that's fine, right? But we can't have a negative distance, so then you would just probably drop the negative, right? So I just did a convenient version of it. Is 2. In the Pythagorean theorem, we're going to square things anyways, right? So we could have negative distances if we want to, because squaring it makes it positive anyways, right? So then between B, we'll call this B, this leg B. What's the distance? We're going from 1 back to negative 5, right? And so I'm going to do 1 minus negative 5 on the x-axis. Right? 1 minus negative 5 is a distance of 6, and you can confirm that on the graph, right? Just count my not very nice looking ticks. We could rewrite this as x1, y1, x2, y2, right? So could rewrite this as x1, y1, x2, y2, which means that we did y2 minus y1, right, to find the distance on the y-axis. So then this becomes, so then A is y2 minus y1. This all feels familiar, right, from the average rate of change, which is finding the slope, right? So we've seen this in other forms before. And then we did x2 minus x1. So if I have A is equal to 2, B is equal to 6, now it doesn't matter which one you name A and which one you name B. They're interchangeable, as long as it's not the hypotenuse, right? The C. Right? So here I'll label this C. So we know that A squared plus B squared equals C squared. And maybe I'll bump this over here. So I'm going to fill it in on the sides. So we have A is 2. So that means that 2 squared plus 6 squared, which is B squared, is equal to C squared. So 40. I'll just oh, I was that's not what I wanted to confirm. 6 squared is 36. Okay, phew. So 40 is equal to c squared, which means that c is going to be the square root of 40. But remember, when we take the square root, right, we get the positive and the negative values out of it. So we get 2 values. And so doing my switcheroo, c is plus minus the square root of 40. But this is where we take, I guess I took a literal step back and we say, okay, well, I can't have a negative distance, right? And so c, so here can't have negative distance. We sort of will allow it later, but so then c is the square root of 40, the positive square root of 40, and the square root of 40 is nothing nice, but that's okay. My calculator just simplifies it to 2 root 10, right? And I know yours does as well, or it can, depending on settings, I guess. Roughly, so c is roughly 6.3245532. So now we've found the distance between 2 points. All right. Or we could have the distance formula, which is just the Pythagorean theorem reworked in terms of the distance c, right? So we don't really need this distance formula, but it's nice to have. So let's just confirm, right? We said that, okay, A, or I guess I called it B. A was in terms of the y's. Oh, and A here as well. Sneaky, Emily. That'd be confusing later, huh? Why did I do that? There. And I should have used A for the X's and B for the Y's, but I think we're all okay with that, right? And so we said that one of the legs is going to be y2 minus y1, and we said that the other leg is going to be x2 minus x1. And so if we look at this distance formula, right, x2 minus x1, we can rewrite, in our case, we had it as B, and y2 minus y1, we had it as A, right? From above. Right. The distance between the x's and the distance between the y's, square those, add them up, right? That's what we did here. Take the distances, square them, add them up. Take the square root. We say, okay, ditch the negative because it's not of interest to us, right? And then we have the distance. Okay. What if you wanted to fix the distance, right? Fix the distance to be r, so the radius of a circle. So now if you ignore the circle part for a little bit, right? Let's just grab this image. So I want you to ignore the circle for a little bit longer. Aha. Ignore the circle. So if we define the center or one of the points as HK, which sounds familiar, right? Because we've looked at the vertex, and so now HK is going to be the center of the circle. Let the point HK be the center of the circle, right? The eventual circle. Yeah. And then if we want to map some point x, y, and I want to force the radius to be some value, right? Then what can I do? I can rework this, right? And I can force the distance to be r, right? So we can force the distance to be r. So then I have r is equal to, let's see here, is it 0.2? Let me just do a little, I want to put them in the right order. Which one am I naming 0.1 and 0.2? I want to go this way, but they go the other way. No, we're good. I'm going to let this be 0.1 and this be 0.2. Which means that in terms of this distance formula, right, then we've got x2 is x, x1 is h. So here we've got, let's let hk be in the place of x1, y1, and xy be in the place of x2, y2. So then I can rewrite this distance formula as r is the square root, I need more room, of, okay, x2 is going to be x, right? x2 is x, x1 is h, so minus h, square it, plus y2 is y, and y1 is k, so y minus k squared. So now we've built the equation for the distance of a fixed radius for any center and any point r units away from that center, right? And so now if you think back to kind of at grade school, I guess, you take your string maybe and you put it in the center and then you pull it out and you want to make a circle with a radius this big, right? And then you draw around it, right? So now this function does the exact same thing, right? You can center it at hk, right? And then we can plug in any value of xy and we can force the radius to be some value, or we can find the radius, right? There are lots of different things that we can solve for. But so it's kind of taken us way back, right? And we're saying, okay, well, then I built this around some arbitrary xy, right? Which means that I could find all the values of xy around this center. So here we're going to say where hk is the center of the circle, and xy is any point on the circle with radius r. No? Wait. Okay. The only difference between where we got to and then the final equation of a circle is that, okay, now I'm gonna move that square over onto the R, right? Clean it up a little bit so I don't have to have a square root that I'm dragging around all the time. So then if I square R, then I'm back to a squared plus b squared equals c squared, right? Essentially. Oh. I'll make a note here. All right. Move the square root. I want to say onto R because that's how my brain works. To the left-hand side from in our equation or in the above equation. Oh. So now we have an equation of a circle. Let's see here. Oh, I keep going into the wrong spot. Let's write an equation for a circle. Write an equation for a circle with its center at 2, -3, and a radius of 5. So now this means that HK is 2, -3, and R is equal to 5. When we write an equation for a circle, we leave the X and the Y spots open because we want to be able to potentially map all the possible X's and Y's. Yeah. And so what we do is, well, we leave X and Y open, right? Just leave them as X and Y. Going back to our linear equations, for example, y equals mx plus b, we need the slope and we need the intercept, but we let X be just X, right? A variable, so that we can plug in any value of X and solve for Y. So it's the same deal. So I'm going to start by writing out my general equation that I'm about to fill in. X minus h squared plus y minus k squared is equal to r squared. Now it's a matter of plugging in values that I have. So h is 2. So x minus 2 squared plus y minus -3. And I'm running out of room here, so I'm going to go +3 immediately. Right? Subtracting a negative makes a positive, or an addition is equal to r squared.
We don't need to reverse the signs like we used
to. Oh no, that's already taken care of in. Yeah. Do you mean the y2 minus y1?
Yeah, just like 2 into things before we have to flip signs to put into.
Oh yeah, so it's a little bit, it's different. It's just straight HK. Yeah. Yeah, because it's listed as HK here. And so it's centered at the point HK. So you can do a direct substitution. Yeah. Nice. And now we're done. Leave. Oops, guess I should capitalize. Leave X and Y as variables. Right. They're X, Y points on the circle, making this the equation of a circle. Nice.
So it doesn't matter if you do the normal R with the root over?
No, that's fine. Yeah. Yeah, it depends on what you want to solve for, right? But if you want to solve for an X or a Y, it's going to be easier to just have the R squared. But if you're trying to solve for R, then it'll be easier to have just R on its own. But either way is fine. you can write this way, or if you prefer, this way is fine as well. I'm happy either way. Okay. Good. What if, what if we wanted to write an equation for this circle? What do we need to write an equation for all the points, all the XY points on this circle? We know we need the center, right? The point in the center. We also need the radius. And so let's figure out where the center is. Looks like it's here. So what is that? 0, -2, 1. Now, initially, it might be tempting to make it look like a triangle again, right? But that's going to be really hard and a lot of work. And so what can you do? Well, the radius should be the same across this way, right? So let's just force that radius. The radius must be 2, right? From -2, it goes to 0, right? So you just pick convenient values on the circle that let you determine the radius, because it'll be the same. Otherwise, it's not a circle. So then the center, HK, is at -2, 1. And the radius is 2. So now we can build our equation of a circle. We said r squared is x minus h squared plus y minus k squared. Yep. Plugging in my values, 2 squared is equal to x. Remember, we want to keep x and y open for business. X minus h, which is -2 squared, plus y minus k, which was 1 squared. Which tells me that 4 is going to be x plus 2 squared plus y minus 1 squared. And that's your equation of the circle. Okay. Let me go in here and make sure I don't miss anything. Okay, good. So from the equation of a circle, what could we do? We can find points on the circle as long as we have one of the x's or the y's, right? So, and then we can solve for the other point, right? And so, for example, if you wanted to figure out what the radius is here, well, I guess we need the radius, but if you wanted to figure out what this point was, all right, let's imagine that scenario. All right. If you want to figure out what this point is, well, I did pick a convenient value for x, right? So I know that x is -1. In fact, I'm forcing it to be -1. So here, x is -1 and y is question mark. What's the problem here? If I force x to be -1, I actually have another option, right? And so here, x is also -1, and y is a different value, right, than the one up top. That's visually clear, right? And so we're going to get two values of y. And where are they going to come from? Well, if I'm trying to get at this y in here, right, I'm going to have to take the square root at some point, right, at some point in the game. And so when I take that square root, I'm going to get a positive version and a negative version, right? And so I get these 2 points. What does that also tell me about a circle? I can't ever write it as a function, right? Because it doesn't pass the vertical line test, right? Crosses at more than 1 point. And so a circle, or the equation of a circle, is not a function anymore, right? Or we can't write it as a function. That's okay. Can still deal with it, right? It's just we're used to functions, and now we're moving out of functions into just equations. So we call them equations, right? Because they have the equal sign. If there's no equal sign in it, it's an expression, but that's nitpicky of me. Right? And so here, I'll just make a note from the equation, and the equation tells me that equation, since a circle is not a function, but there is an equal sign. That's what makes it an equation. All right. So let's say find the values of y at x equal to -1. Let's do that. We have the equation of the circle set up already. And so I'm going to force x to be -1. And I'm just going to snag this here. Copy. Paste. So then I get 4 is -1 plus 2 squared plus y minus 1 squared. Okay. -1 plus 2 is 1. 1 squared, I'm just going to go straight to 1. Plus y minus 1 squared. I have to get the y minus 1 squared on its own before I can take the square root of both sides, which means I have to have 4 minus 1, but I think we're grown up enough mathematically to just go straight to 3. 3 is y minus 1 squared. If I take the square root of both sides, I get the plus minus root of 3 is y minus 1. Taking the square root of both sides. So then here, don't forget this, that little guy, because that's how you're going to get 2 possible values for y, right? And we need those 2 values. There isn't just one, there's 2, right? And so now we have y minus 1 is plus minus the root of 3, or if I add this over to the other side, but in the same move, 1 plus minus the root of 3. Add 1 to both sides, and then plus minus works as a plus or minus. I want to say plus and minus, but you can't do them at the same time. But we need both of them. So then y is 1 plus root of 3 and 1 minus the root of 3. Right. We've seen that before. We're no strangers to this notation because we've been using the quadratic formula out the wazoo. So then if I copy here, just make a smaller version. We found that if I do 1 plus the root of 3, I get roughly 2.732, and 1 minus the root of 3, I get roughly negative 0.732. So then here, roughly 732. The reason I want you to think about what it is approximately, I love exact values, but in order to confirm that what I found makes sense, right, it's easier to look at the decimal value. And so here, y is 2.732-ish, and here y is negative 0.732, which again, just make sure that it makes sense. Somewhere between 0 and -1 looks good to me.
We can do that just simply with a squared, with b squared goes by itself, right? With one side just being 1, one side being 2. We're just solving for
You can.
1.
Yeah, so there are other ways. I find that this one's just a little bit quicker because it's got the Pythagorean theorem built in here. But if you wanted to brute force it, find the two, just remember that you have 2 points, right? So that's going to be the key. So you don't forget about one of them. But yeah, you could just use the Pythagorean formula if you want. Right? Forcing r to be 2, forcing 0.1 to be -2.1. Go for it. Go for it. How about we have another example? We want to find the y-intercepts of x plus 1 squared plus y minus 2 squared is equal to 9. We can pull some key information here, right? Where's the center?
1 minus 2.
Nice. Or is it switcheroo those maybe? Yeah, that's what I had to go back and confirm. So it is x minus h, which means it's, yeah, nice. So then here, the center must be at -1, 2. Just looking at this equation. What's the radius? Nice, must be 3 because 3 squared is 9, or you can take the square root of 9 and then recognize that you can only have a positive radius. Right. Can't have it moving into itself. It's weird. And so, right, just from the equation of the circle, we know some key things. Okay, so if we want to find the y-intercepts, just like always, it's going to be helpful to have some sketch of this scenario in our minds. Okay? And let's see here. Can I move this? Give myself more space. Let's plop our center down. -1, 2. I'm just gonna make values I went out too far, probably. I'll move this. Hey. So -1, 2. I'm going to force my radius to be 3. So from -1, just as a kind of a check-in point, -1, I'm going to move 1, 2, which means that this is one of the points on the circle, right? If I go straight up from 2, then I'm forcing the radius to be a distance of 3. So now I've got my string tethered at -1, 2, and then what can I do? I can draw a circle around this way, and let's see if I can do something fun. Okay. But can I move it? I can't. Ish. Technology. Gonna extend these things. So just like before, we can talk about x-intercepts, right? Where does it cross the x-axis? Not all circles are going to cross the x-axis. That's fine, right? And so then your center would be too far away to cross the x-axis. We can cross the y-axis. In fact, we cross it at 2 points, right? And so we can find x and y intercepts just like we did before. So we want the y-intercepts, which means I have to extend this a little bit. So here and here are my y-intercepts. Okay. At my y-intercepts, I know that x must be 0. That's nice. So I have the equation of my circle, and so what can I do? I can plug in x equals 0 and solve for y. Now, none of this, you didn't need to do any of this, right? But it's our kind of our starting one. And so I just want you to see all the things that you can extract out of just this statement, right? Center, the radius, the sketch, right? Visualize it. But if you wanted to just jump from the y-intercept, well, at the y-intercept, I know x is 0, plug in x is equal to 0, solve for y, you're done, right? That's really all it's asking us to do, but have a little fun. I'm going to write 9 is x plus 1 squared plus y minus 2 squared. X equals, or I should do an arrow. Let x be 0, then 9 is 0 plus 1 squared plus y minus 2 squared. Nine is 1 squared, which is 1 plus y minus 2 squared. Again, we need to get y minus 2 squared on its own before I can take the square root. And so I need to move this 1 over to the left. So 9 minus 1 is 8. 9 minus 2 squared. taking the square root of both sides and plus minus, right? Because we know, and you would have caught yourself, right? Later, if you forgot the plus minus, you would catch yourself when you try to report the results, especially if you're trying to map them to the points, you would say, oh, I forgot the plus minus, go back at it, right? Because you know you need two values of y. And so you need plus minus the root of 8 is y minus 2. And I'll highlight plus minus again. I'll stop highlighting it at some point, but it is important. And I think the reason I harp on it so much is because I forget it all the time. When I take the square root, usually the negative option doesn't apply anyways. And so I get really sloppy when I take the square root and I only consider the positive option. And so I think that's why I'm harping on it so bad. It's for me to remember as well. So then y is going to be 2 plus minus the root of 8. Just kind of steering things up, making it look nice in the last line here. What did I do? I added 2 to both sides. And then because I've got the plus minus, technically you could have plus minus the root of 8 plus 2, but that looks weird. And it could be confusing when you're reading it, unless you do a proper little closure on the square root, right? So usually I do a little closure on the square root if I need to indicate to myself that that's all that's getting square rooted, right? Otherwise, you might be tempted to rewrite it as the square root of 8 plus 2, so the square root of 10, which is completely different, right? So there are a couple of reasons why I write it this way, right? Is because then there's no other option for the square root. It is just the square root of 8. So approximately y is roughly, and I sense I'm going to have kind of big values here, 2 plus the root of 8 is, well, 2 plus 2 root 2, roughly 4.828427125. And 2 minus root 8, roughly negative 0.828427127. The exact answer is this, right? Y is 2 plus minus the root of 8. Yeah. So these points then, right, we forced x to be 0, so I already know one of the coordinates is 0. And then this is my negative y. I can tell just because of where it is on the on our grid, right? And so I'm going to say negative 0.83. Let's go really crazy. Round to 2 decimal places. I know, I don't know what got into me. 0 and 4.83 for symmetry. Are our y-intercepts. Nice. How about another example? The unit circle is a circle with radius 1. So that's a definition, I guess. And he's probably got one of those nice green boxes for it. And I'll bring it in once I'm back in there. But for now, just remember that the unit circle is a way of saying, okay, it has a radius of 1. So then if we just ignore this, x squared plus y squared equals Oh, is another condition of the unit circle that it's centered at the origin, 0, 0? It is, right? Thank you. Another condition and another one centered at 0, 0. So now if we think about our general equation, r squared is x minus h squared plus y minus k squared. H is 0 and k is 0 and r is 1. So plugging in those values, I get 1 squared is 0. Oops. X minus 0 squared plus y minus 0 squared. Which makes 1 is equal to x squared plus y squared. Little cutie. Which is where they got this from, and also my clue that it would have to be centered at 0, 0, right? Because from each of the x's and y's, I've subtracted 0, right? And so, but we're given the unit circle, but I want to introduce where it came from. And so we're going to find x when y is 1/2. So we want, and I'm going to rewrite just like they have it, x squared plus y squared is 1. And we're going to let y be 1/2. So x squared is 1/2 squared, which is, oh my gosh. Just creating equal signs, plus. We can flex our exponent muscles, right? What can I do if I have 1/2? Wait, well, I could cross it out, but that's not what I meant to do. Write it cleaner. If I have 1/2 to the power of 2, the distribution law says that I can bring this 2 inside as long as I'm multiplying or dividing inside, right? And so I can rewrite this as x squared plus 1 squared over 2 squared is equal to 1. That's really just to practice our kind of exponent laws still. This is going to be 1/4, right? You can use your calculator too, if you wanted to. And so x squared is going to be 1 minus 1/4. So from here, x squared is 1 minus 1/4. Oh, practice our fractions. Adding, subtracting fractions, I have to have a common denominator. So then what my go-to move, which is a little bit less elegant than kind of other techniques, but I always force it to be the same, not the lowest common denominator. And so then I multiply 1 by 4/4, right? Multiplying by 1, 4 divided by 4 is 1. So my go-to move is I multiply by 4/4 times 1, right? 1 times 1 is still 1. I haven't altered anything. And then I have 4 times 1 is 4 divided by 4. So now I have x squared is 4 minus 1 divided by 4. The reason I'm allowed to merge those, remember, because it's been a while since we've worked with fractions, I guess, is because they have a common denominator now. So now I have 3/4, or if you just in your head did 1 minus 1/4 makes 3/4, or using your calculator, that's fine too, right? But these are all skills that we have. So then x squared, I guess I can put it on a, it's driving me bonkers that these lines at the end of at the page break don't line up. But x squared is 3/4. So now solving for x, right? I take the square root of both sides. X is plus minus the root of 3/4. Which is some value. Wow. X is roughly negative 0.866-ish. I know, it's so impressive that I was able to rein it in. There's more. Or negative version, 0.866-ish. Makes sense, because if you're centered at the origin, right, then 0, 0, then moving out a radius of 1 should get you to the same value of x, right? Okay. Nice. Good. Gonna get crazy. What if we want to find the intersection of x squared plus y squared equal to 16 and a straight line 3 minus x, right? This straight line we know has a y-intercept at 3 and a slope of -1, right? And so what we can do is we can sketch out both of these. And I can't remember if Desmos makes circles or if it only works with functions.
It does.
It does? Nice. So then we'll confirm it and have a look in Desmos, but let's make the sketch. Thank you, thank you. Where's my center? Well, 0, 0, right? Because there's nothing happening on either x or y. So then my center must be, hey, 0, 0. My radius has to be the square root of 16. So then I have r equal to 4. So then if I kind of make 1, 2, 3, 4. See if it'll, oh no, it didn't do its fancy thing. That's my circle, I guess. Oh, well, get the picture. R equals 4. Okay, so then if r equals 4, uh-oh, just a sketch, means that this must also be at +4, right? In fact, at all these axes, right, it'll be at some version of 4 plus minus 4, right? Because we took the square root of 60.
So if it's just x squared and y squared, that tells you it's one of those fancy circles? Is that...
Yeah, so this tells me that the origin, this is centered at 0, 0. Because for the general equation, it's x minus h and y minus k. But if there's nothing being subtracted, then it's 0, 0. Nice. Okay. Wow, my colors don't match at all. Gonna rectify that by doing ding. Nice. Okay, how about 3 minus x, right? So here, this has a y-intercept of 3 is 0, 3. Let's make, I don't know, this 3. It doesn't work with my lines, but we're just trying to grasp the scenario. Okay. So now, if I'm crossing at 3 and then I have a slope of -1, right, then I know it's going to look something like this. Now, I'm a little bit curious what the value of x is going to be when y is 0, right, for my sketch. So just briefly, I'm going to let y be 0. 0 equals 3 minus x. So then I can move this over here and say x is equal to 3. So here, notice when y is equal to 0, x is equal to 3. Wait. It's equal to 3, which tells me that it's going to go through this point. In order to draw a line or sketch a line, you need 2 points on the line. Now, in theory, you could have put in any value of x here and solved for the y, but only some of them are easy to sketch on our pseudo graph. But once you have these two, right, you draw a line. Let's see if I can pull this off. Through both of them, use a straight edge or technology and extend the line. Okay, nice. So here and here, roughly, right? My graph isn't very good, but now I have a general understanding of what I need to do. Yeah? And so I want to find the intersection of this circle and this line. Okay, so I'm going to have 2 points. What's something I could do? I could make a substitution, right? I could say, well, usually when I'm trying to solve for the intersections of 2 lines, then I have 2 functions and I can set them equal to each other. We're going to do a similar thing, except now, so we're given y is equal to 3 minus x, right? From up here, f of x, you can rewrite it as y, right? And so now we can substitute 3 minus x into our y up here. So now substitute into the circle equation. Okay. X squared plus y squared is equal to 16, and we're going to force y to be 3 minus x squared. So I get x squared plus 3 minus x squared is 16. Clean this up a little bit. 3 minus x squared, right? You don't want to be distributing the square because we're adding or subtracting inside, which means, oh, I have to expand this thing. So let's get to work. X squared plus 3 minus x times 3 minus x is equal to 16. I want to find now the value of x that makes this happen, right? Once we have x here, then we can solve, right? Then we're going to have a value of x here and a value of x here. And then we can substitute those values of x either into the circle or into the line. They should be the same for the values of y, right? Because it's the intersection. Okay, x squared plus 3 times 3 is 9. I'm going to put it in brackets. 3 times negative x is minus 3x. Negative x times 3 is minus 3x. Negative x times negative x is x squared plus x squared is equal to 16. Hey, shaping up to something that we're okay with. Right, making sure that you keep brackets around it. Here we're adding, so it's not a concern, right? Addition and subtraction just creates subtraction. But if you had subtraction here, then you would have to distribute that negative inside, right? And so here we get X squared, I'll write it out clean first. 9, I will combine my -3 minus 3 to -6x plus x squared is equal to 16. Combining like terms and listing them in decreasing orders powers of x, I get 2x squared minus 6x plus 9 is equal to 16. Hey, we're back to a quadratic, which we know how to solve. I can solve for where x is equal to 0 as long as I move this 16 over. So then I get 2x squared minus 6x plus 9 minus 16 is equal to 0. Okay, we're doing it. 9 minus 16, so I don't mess things up too bad. 2x squared minus 6x minus 7 is equal to 0. So a is 2 in my quadratic formula, b is -6, and c is -7. You might have the gift, I do not, so I don't waste my time trying to find factors or anything. I just go for the quadratic equation. I don't see them. X is negative b plus minus the square root of b squared minus 4ac over 2a. So x is going to be -6 plus minus the square root of -6 squared minus 4 times a, which is 2, and c, which is -7, divided by 2 times 2. What's something that we look out for in the square root? I can't take the square root of a negative number, right? But should be okay. Let's see here. I'm gonna do 4 times 2 times -7 is -56. So kind of hodgepodge math here. 6 squared, 36 plus 56. That's what I get. So I get x is 6 plus minus the square root of 92. Hopefully I didn't do that wrong. Nice. Okay. So now, using your calculator, of course, x is 6 plus the root of 92 divided by 4, and 6 minus the root of 92 divided by 4. 6 plus the root of 92 divided by 4 is roughly 3.8979157662. It's a compulsion. 6 minus the root of 92 divided by 4 is roughly, play it cool, Emily. No, I can't. -0.8979157617. Okay, nice. So let's say to 3 decimal places, x is roughly 3.898 and -0.898. Let's not get crazy. You could use the exact values, but what does that mean? Oh, do I have to copy this? My ugly circle. Whoa. I'm gonna delete this though. Wait. Oh, actually that paid off. Can redo my circle. And I guess my line, but I have the components. Whew, not that much. Whoa, yeah. Oh yeah, we're in the money now. Okay, it's not working. Just pretend, or I guess I can do this. Make this 3. Just a rough idea. Okay, so here we found that this, right, must be this point here, negative 0.898. So when x is negative 0.898, I can solve for y. Now I have an easy option to solve for y, which is the line, right? I can plug in y equals negative 0.898 and solve for y. Or I can use the circle if you want to. A little bit wild and crazy, right? You're saying x is negative 0.898, then square it, and then take it away from 16, and then take the square root, and you're going to get the same value of y as if you just plug it into 3 minus x. So I'll let you choose, but I've made my decision. So if I let x be negative 0.898, then y is 3 minus x, which means y is 3 minus negative 0.898. And so I get 3, y is 3 plus 0.898, so I'm adding. You always want to check in, right, and make sure that that value makes sense. On here, looks good, right? We're expecting it to be larger than 3, right? And can't be 4 because that's the highest point of my circle and I'm already on the downward slope. So I'm expecting my value to be between 3 and 4, right? And so here, this point is at negative 0.898 and 3.898. If I do the same thing again, if I let x be, what was it? 3.898, then y is 3 minus 3.898, which means my y is negative 0.898, which again makes sense because I'm below the x, I'm expecting to be below the x-axis, right? And so here, this is at 3.898, negative 0.898. And I could feel it. We're out of time, I think. Yeah. To confirm. Okay. So we'll keep working on that, but pretty fun. And I think, let me see here. There's an example for you to think about. Kind of cute. A word problem. And we're gonna start with this on Friday. So I'll put it in here, can think about it. Wow.
It's one of the weirdest scenarios.
That's why I had to keep it because it's so funny. It's like, wow, how did you come up with this? And morbid. Okay, stop this recording. If you have any questions, let me know. Otherwise, see you Friday. For our last Friday, really.